Thank you very much, Jose Luis, and thank you very much for the invitation. It's a great opportunity for us to be here to explore cooperation possibilities. And so it's a great pleasure. As you can see, it's many people involved on that. We prepare this microgrid tutorial based on the work we developed in the task force with Claudio Cañizares. And on the left, you can see the group in the Energy Center at the University of Chile. On the right, the group with Claudio. And this is also closely related with the structure of the presentation. You need to support me near to 3 hours, so it's very complicated. Yes, and the idea is to have some exchange. Please interrupt me if you want to clarify something or to discuss. The main idea is go through the 2 parts. The first part related with planning more, design of microgrids, and the second part with the topics of operation. Some issues about primary, secondary, and tertiary control, and also some topics about stability. Let me see if it works here. Yes. The first part is divided in a brief introduction. Then I will talk you about what we explore with our team and what we call co-construction methodology for planning of microgrids. Of course, as you know, microgrids is contextualized for the local requirements. So I will talk about our experience from the Chilean perspective. Perhaps it is different in Germany and other countries. And I hope you can make bridges with your local context. Then I want to talk to you about more specific planning tools, and finally to summarize the conclusions and challenges. Definitions. I am here in a forum of experts, so I will be very, very quick on that. We go very fast on that topic. What we observe, and this is a world trend, that climate change, energy cost, high dependency, and also social opposition to the conventional or traditional structure of centralized energy system is more or less the origin of the pressure or of the opportunity for the development of decentralized solutions. And I share completely the view of Antonio that in the future we will see no one winner of that. We will see perhaps a combination or a share between centralized solutions, renewal or not renewal, and also decentralized solutions. And this is the origin and the motivation of this type of structure that you can see in the picture, where we have 2 main issues: power electronic developments. We will see later a presentation on that. Development involves the capability of the new equipment, but also the lower prices that we observe, and also renewable energy maturity in many of the technologies that we can today, together with communication capabilities, integrate in a very efficient manner. And the challenge is how to share that in the context of a power system with stability standards, with system adequacy, and of course, at the end, from the sustainable point of view, that we achieve also cost effectiveness. If we are not able to do that, we can make many efforts, perhaps from the point of view of equity of the governments and some of the applications, but we will not see a high penetration of these solutions. In the introduction, again, a microgrid concept. We have a distribution network, a new type of distribution network, as you can see in the picture. We'll have a connection, a point of common coupling with the system. This is the physical part, but we will also have a unit for centralized communication that is able to have a communication with all the equipments and the different loads and offers, inclusive electrical vehicles that you will have in the system. The objective is how to incorporate this decentralized solution, how to provide control and power supply, and also in the framework of power quality and reliability of the system, And at the end, I repeat the idea of cost effectiveness in that solution. A definition of microgrid, I will skip this. You will have this as backup in your material, but you have a small grid of some kilowatt and megawatts. There is not clear definition of the border. You can have a very small microgrid. This is usually the context in Chile today, but also you can achieve megawatt microgrids. So we have a wide range of issues, and you will incorporate loads with some control capabilities, and you will incorporate decentralized energy sources, and of course also storage devices. We observe, and this is the context from where I am coming, in Latin America, we published that on IEEE, we observe an increase of initiatives in microgrids in different levels. Some of them are islands, like the Eastern Island, where they are developing and trying to move the island to a more renewable microgrid. Today, the Eastern Island is 100% diesel generation, and this is a condition not accepted by the inhabitants or the people in the island. And several initiatives in Brazil, in Chile, etc., that is able to create like type of solutions that we want to replicate in the near future. We see, in a more general sense, the microgrid solutions as part of three pillars. On the left, one of the pillars of the future development is energy efficiency, and I will not talk about this. On the right side, one of the pillars of the energy development is the traditional supply solutions, some of them fossil fuels, but we observe an increase in re-understanding of hydropower. I talk about re-understanding because the traditional way we observe hydropower, at least in Chile, is today very conflictive from the social point of view, and there is a big discussion in society how we try to see hydropower in a new context. And of course, transmission expansion and large and scale non-conventional solutions like renewables. This is the case in the case of Chile compared with Antonio. I will make some bridges with the presentation from Antonio. It's not 2018 in Chile. In Chile, we have today around 3 gigawatt, more than 3 gigawatt from 21 gigawatt installed capacity in the country of non-conventional renewables. This is not including the big hydropower, and only 20 megawatts of distributed generation. So it's like 0-100. Our combination is near to zero, the distributed generation. So compared with Germany, for example, or Australia, there's a complete different trend in our country related with this type of solutions. And my presentation will concentrate on the central pillar, integration of huge potential of renewable-based distributed energy resources, especially in the form of microgrids, and we see then three types of microgrids: the coordinated, islanding, and emergency microgrids. What's the meaning of that? What we call coordinated, integrated, distributed renewable energy or coordinated microgrids. It can be in the form of a virtual power plant or in a microgrid connected to the grid. When we talk about the island microgrid, is islanding microgrids, which is a typical issue in physical island, but also in more isolated parts in our country where the network is far away or it's not economic to develop a connection with the network. And finally, you know, Chile is, every month we have a tsunami or earthquake or something like this. So we are very sensible with the concept of emergency systems. Emergency microgrids is a type of solution that can support emergencies in the different cities, how to have a safe or a secure part of the system able to provide some basic assistance during this type of emergencies. And we are trying to develop some concepts, of course, very different in the sense of reliability compared with the previous two ones. These are the three types of microgrids we developed. Microgrids opportunities, of course, remote locations are a main microgrid development opportunity in our context. Remote off-grid microgrids are best hope for developing world, according to the United Nations, and we see a real potential not only to develop what you call like a social support. We are talking on solutions that can be defined as, from the economists, they talk about impact investment. Impact investment are solutions that are able to provide labor opportunities and also some efficient new businesses for the communities where they are located. Part of the solution of climate change, at the end, these small microgrids, if you make the amount of emissions that they can avoid, is very small. So it's very tricky to go in that line in this type of solutions as argument. And again, for physical island, is the most attractive remote opportunity today because of the high fuels cost and supply vulnerability, and single negotiation party entity for larger scale systems. This is the concept we developed in the case of Chile. The technology drivers was impressive, as mentioned before, the declining cost of solar PV as one of the drivers, high cost of diesel, this is very variable. This is why I put the question mark, because it is a thing that changes from year to year. Nobody can say for next year how we will be the trend for these prices. But because of climate change, many people are saying, regardless of the future price, we need to move far away from this trend. And three primary segments where we apply that is commodity extraction systems, in physical island, in village electrification. This is three examples that I will go in much more detail in the next slides. Only to give you a final perspective of where are the numbers in Chile or in Latin America. The coverage in Chile is very high of electricity, is around 98%, but the definition of coverage can be 7 hours, 8 hours a day electricity. So if you go in a double click in the definition, you can see that there is a huge space for the development of microgrids. And of course, in the same Latin America, you can see Haiti or other countries like Honduras, where you see numbers that are much more interesting in the sense that the challenges are very big for the coverage too. So let me go to a perhaps different topic for you. As mentioned at the beginning of today of the meeting, this is an interdisciplinary field. In our case, we face that since 8 years in a very clear way. And interdisciplinary is not only for engineers in our case. We incorporate people from social science. And this is the topic that I want to cover with the co-construction methodology. What is behind that? What we create in a microgrid, in our understanding, after many, many discussions, is that at the end what we create is a socio-technical system. This is the definitions. You never developed a technical solution. This is no more the case, at least in our country. If you observe the number of projects that after 2 years are without maintenance, or no more in operation because of technical issues or because of the non-engagement of the community, you arrive to the conclusions that the only way to achieve or to have an opportunity to achieve a sustainable and resilient socio-technical system is to work with the community, not only a community in a rural area, far away, indigenous community or something like this, of course in that case, but also in urban, inside the cities. You need to work with the community during the design of the project. And this is how we develop with this objective a team, a multidisciplinary area in our energy center. And in this area, we have agronomists, anthropologists, sociologists, natural resource engineers since 5 years. And we create a new area that work together with us. I want to mention that in our experience, to put researchers, senior researchers from the social field was not successfully for us. What we built is we cooperate with people from social science, but we incorporate young people or people with a profile that can make a bridge with social science. I don't know, and it could be an interesting topic for discussion. For us, the solution to put senior engineers together with senior social science, at the end, what you observe is more a conflict instead common work. And for us, what work today is to have a own group that is able to make the bridge with them. And of course, we never say that we are working in a very deep manner in the social topics, because we are not making research on that area. We are from the corner, we arrive from the corner of the engineering side, and we look the problem from this corner. This is an important message for you from our experience. There are some key concepts that our people from social science work, how to conceive the complexity of the problem and to develop a general theoretical framework, what we call the socio-technical system, as mentioned before. For what? For transitions to a new energy development, how we achieve resilience, and how we achieve transdisciplinary co-construction. Transdisciplinary is very idealistic. At the end, what we have today, in the best experience that we have achieved, is interdisciplinary work. You know the difference between these concepts. Transdisciplinary is really to create new knowledge from a group of people from different areas, including people from the community. In the case of interdisciplinary, at least you work together to solve the problem or to solve the challenge. The approach that we create is called co-construction and is developed in these 4 stages. The first stage, and I will explain you each stage with some examples, is what we call socio-technical, diagnostic, and team building. So it's from the very beginning, when you define the team that will cover and will deal with the challenge, you need to be careful to select the people. The second one is socio-technical design and sustainability plan. Third stage, this is chronological, implementation and first impression. And at the end, you need to arrive to the operation, evaluation, and dissemination of the results. Here you can see some specific topics or activities that you cover in each stage. For example, in the first stage, you need to share principles of transdisciplinarity to define the borders. You need to be very clear at the beginning of the project, if you have a specific budget, to say this is the border. We don't have more budget like this. This is one border. Or things from the technical point of view that you are not able to move. But inside the borders, you need to have space to discuss with the community for the final design. If not, you will do the project, you will operate the project, you will give the final answer, you will receive the money for that. The problem is 2 or 3 years later, not at the moment. At the moment, all the projects at the end work because the people work hard to do that. But the question is if they really are sustainable. Let me go through the different steps to explain you a little bit more. This is our first microgrid developed in Chile in 2010. It's a village in the desert in the north near to Iquique. And we developed this photovoltaic system, 23 kilowatts. When we arrived to Huatacondo, it was a village with only 7 hours per day diesel generation. And since 2010, we are able to say that they have 24 hours with the penetration of renewables on around 60%. This is the penetration of solar, and at the beginning also with the wind turbine. For that town, and also in the Eastern Island, in this stage 1, the things that we developed were things perhaps new for us as engineers. One of the concepts is team formation, as mentioned before, gathering information. That what you can see in the picture, I will show you a little bit later a bigger photo. We developed a scale model from the island, because after this is the Eastern Island. We worked for 1 year with the people in the Eastern Island to develop the energy plan. In our first visit, the reaction of the people in the island was very negative to us. They start to talk about all the bad histories with the University of Chile, where I belong, and many issues. And a second thing that they talk is, we don't like any picture with PowerPoint. Go out with these stupid pictures. We want to have a conversation. How to develop a conversation, and the way we did that was based on these scale models, and it was a nice effort to create this picture of the island. And with this scale model, in 5 months, we have a very good conversation about the energy of the island. Because you can say, here is my family, here we need energy from here to here. And this is how you remove barriers for communication. And this is not only in very specific place like the Eastern Island. In our experience, what we use this type of tools are called boundary objects. The use of boundary objects is a tool that is able to open a discussion and to plane the conversation in any case. Let me show you the different trainings and ideas in Guatacondo, in this town. In 2010, we made a similar thing. This is not a picture from the town. It's again a scale model, and the people working in the town, they define where finally was the location of the PV, as shown in the previous photo. This is before the creation of that. The other photography is from here, so you see the photovoltaic panels here and the wind turbine in this point. And this was not planned. We were not able to design the final location before the starting of the project. So after that, you need to adjust the solution for the transmission, like the distance from the wind power, around 1 kilometer to the town in low voltage. So you need to achieve some solution for the losses, etc., etc. This is a better picture from the scale model from the Eastern Island, and the people on the right are discussing the colors of these feeders, the colors of the different energy drivers, like wood, like fuel, like gas, and they explain us how they use the energy in the system. Because in this case, our work was how to develop an energy plan for the island. Another interesting tool in the case of the Eastern Island was, the Moais in the Eastern Island, and the people in the island are very sensible to all the archaeological history of the island. And the first position is, you are not able to touch nothing. It's prohibited to touch anything in the island. How to develop, if you start like this and you want to put a photovoltaic panel and wind turbine, which will have an impact on the landscape, it's very complicated. So what we developed was, this is a projection of a map in the floor from a normal projector like this, and we are able to put this type of layers. This is, for example, the protection. We'll show you later a better picture. The protection areas because of the urban development of the island. So you can touch these areas. And with this discussion, we are able to, after they accept that we need to do something, let us discuss and put together one after other the different constraints and to see where we can develop the island. How you do that in a model without discussion with the community. And this is our experience. We can use Homer, we can use many tools that are available today to develop some solutions, but at the end, you need to work together with the community to really achieve a legitimate solution for the people in the island. Of course, what we do internally is to use all what we know from engineering science. What we develop in the case of our tools is the knowledge about the research, in this case load evolution, load forecasting, wind, solar. We have tools that are able to minimize the traditional one, the present value of the photovoltaic, wind, batteries, or storage and generation solutions in this case, and to achieve an optimal mix. This is the typical trend that we also use, and I will show you later a more detailed example. With this type of tools, we can explore many solutions. We are looking for not only one optimum, we want to explore like the Pareto efficient border of that. And what you can see here, I don't know if we can remove this here. I think yes. Let me try only to see the whole picture. Yes. This is the total capital cost for generation at the network. And here is the main monthly payment in Chilean pesos from the people in the town. And with this, you have a combination of solutions. And we identify some interesting points that we will discuss later. And there are some solutions that can be used as reference, like the minimum present value from the optimal design from the previous one. But, for example, you can imagine that if you have experience in this type of solutions, that a key point for the sustainability is the capability of the community to replace the storage system when they achieve the expected lifetime. In that regard, if you see that the minimum replacement value for the new equipment is this point, although this is more expensive in the capital cost compared with another solution like this, that could be the minimum present value of the sum. At the end, if you are looking for sustainability, it might be better to go to the border of the budget instead to use the minimum traditional present value of the cost. These are the type of discussion that you have with the community when you design this type of solutions. Let me go again. After that, as you mentioned, keep in mind that we are looking only, yes, very fast, the different stages. I finished with stage 1, and we go to stage 2 for the final design of the town. In the case of Guatacondo, we arrive to a solution like the solution shown in the picture with this type of tools. We develop the final solution. We also develop a communication system. A key topic for this type of community is that you are not able to put an engineer 24 hours the day looking for the system, like a big SCADA system. So the level of automation of the system might be very high, and you need to be able to train a person of the community to operate the network and to solve 95% of the problems or the issues in the network. Of course, you will have a remaining number of issues that are not feasible to solve locally, and you need to have and to develop in the country like a support network or companies that are able to support the maintenance of these solutions. This is our operator, Felix, in Huatacondo, who is the local one, and today an expert in operation of microgrids. And the next step is that he is able, if we increase the number of microgrids in Chile, he knows very well the language that he needs to use to train the trainers, which is a very important way to expand this type of solutions in a country. At the moment, we are at the very beginning. We have few people that are able to work, and we understand this is part of the topics that is good that the universities are involved, but later we need to create companies that move that, because this is, in the long term, can be an issue for the universities, and at least in my point of view. This is our final solution in Huatacondo, with wind power, an existing solar panel, a little watt that we incorporate to the network, and we develop this battery energy storage system to be able to make a centralized operation of that. It's a very conventional, ad hoc, centralized control system that we can discuss later. This is the operation, and the result, we have like a unit commitment. In all these hours, let me go here, the operation during the day is without diesel and only in the night. In black, we start the diesel generation, which is responsible to supply the load in the town, but also to recharge the batteries at the new level to restart the day or the next day. You can see the load, and you can see that during the night there is full battery support system, and the voltage in the battery decrease, and when we start the day with a very good sun, at the beginning of the day, this is a tracking system, one-axis tracking system. This is why you see that the ramp is very high. And you can see that you can recharge, and we have not very good behavior and treatment of the battery system with all these changes. And of course, for that, if you want to smooth that, there are very good technical questions like to incorporate some buffer with ultracapacitors or something like this to have a good impact in the lifetime or the state of health of the batteries. This is the tracking system that in Chile, in all the north, this is not the situation in Germany or Italy or I don't know in Spain, but the direct radiation in Chile is very high. So we need to use one tracking system at least. You will win around 35% of energy additionally, and you use less than 1% of energy to move the system. So if you have a good solution, in this case we have linear actuators. It was developed by us. Today are much more better systems. And this is the nice combination in microgrids, that you can use the good things from the big photovoltaic power plants, like the tracking systems, because they are tracking system for 30, 50 kilowatts. So you can use that in the microgrid, and also use the advantages of the microgrid. For example, a very low-cost cleaning strategy, because the same people of the town are able to incorporate the cleaning of the panel as part of the involvement in the solution. So you have the best from the community side and the best from the big power plants compared with the roof, top roof installation of a fixed PV. This is again a message. This is a contextualized. Perhaps this type of systems, the advantages are not very clear in a country like Denmark, because there is no advantage to have a tracking system, and tracking systems are completely not a good solution for a house on the roof. So you need to develop microgrids, have a special situation in, at least in the case of Chile. About adjustments of the design. When we start with the project in Guatacondo, we incorporate a wind unit, a Chinese, like you see in the picture, but the original one was without this cage, without this protection. When we arrived to the town, again, this is very difficult to see before you start with the project. Guatacondo in Aymara, is the indigenous language, means the location for the condor bird. And you can see in the surrounding area many condors. And when we asked to a biologist, they said, if you put this, you will kill condors. So we need to redesign and to adjust a protection system, 6 months of delay of the project because of that, at least this part of the project. And again, if you are able to see that before, you are impressive smart. We were, and in every new project that we are involved, we identify new issues. And I can tell you many, many histories about redesign that we need to cover during the project. And this is why we justify this co-construction. If you don't do that and you put the solution that we plan with the technical team, you can do that, but you can face that a condor will kill and nobody will have more trust in the team in the future because of that. And the reputation of the solution, please?
Did it help? Was any condor killed afterwards?
No. And no condor in the surrounding area. There is no evidence that the biologist is right, but it's like that was not important. At the end, it was an official position from a professional. We are not biologists. We can ask another one. It's the same opinion. At the end, you need to follow. It's like the safety instructions. Yeah, you can't do that against them. For talking about how we adapt, we developed with the idea of the wind turbine that is far away from the location of the town to deal with this low voltage. It was space to test an idea from the University of Madison. A group of students, they developed the reusage of the transformer from the microwaves, where you can use, you know that the microwaves in our system with 220 volts, they increase the voltage around 10 times, 2,000 volts. So, and this transformer is a good quality transformer that you can use as a microformer. And we put it out from the microformers and we develop the connection of the wind turbine with inside this type of solutions, the microformer, and in that way we avoid the losses from this long distance. And again, in our case, this is not a commercial one, but it's a safety one, made with all the rules that you can adapt solutions to deal with a new scenario that you need to cover. There are many places in the world where a village is composed by houses that are not near. So you have 2 kilometers, 3 kilometers, and the normal answer to that is we need to develop autarkic systems, like isolated systems, because if you try to develop a high voltage or mid voltage, it is quite expensive, and you arrive to isolated solutions. With all the disadvantages of that, there are also advantages. But if you have a community, perhaps the diversity is much more better if you can reuse such. This is one idea related with this. Going to stage 4, sustainability indicators are one of the things that you need to develop for the future. So it's like a SCADA system that you want to develop with the people to show how the system evolves. This is especially important because normally the microgrid is invisible, and electricity is invisible for the community. And if you want involvement, you need to have like a window to the system. So the energy rates and payment need to be justified with these sustainability indicators. How do you develop operation and maintenance? How you develop a local management structure, and how you develop the communication channels. These are the minimum number of issues that you need to incorporate in a project, microgrid project, for the final stage, stage 4. This is a picture of our social SCADA. There are many today commercial solutions. We call it social SCADA in one of the journals that we publish in IEEE. The idea of social is to say, okay, we need a SCADA system, but it's a SCADA system where the main use is by the community, and this is the meaning of social behind that. And we develop a physical and a virtual, like traffic lamp, where we can say for the demand side management, to say we are here in the hour, so in these slots of hours, you don't need to be careful with the energy. We will have enough energy. You need to be careful always, but you can work as usual. And if you have red, that you can say to the people, please avoid the consumption of energy during these hours. This is like a feedback that you can give to the community. This is a work in progress. It's very complex to incorporate this type of behavior. Here you can see the social SCADA installed in the community in a board like this, and showing the different aspects. This is the logo. I can identify the Condor Bird again. Finally, in stage 4, we also looking for the future. You start a project and you identify a new project during the project development. And one of the interesting issues, and we are working on that today, is that the incorporation in the microgrid of electromobility. But a very special electromobility to carry waste, to go to the farms in the surrounding area, to bring all the tools and bring back the production, this type of tools. And we see that also as a new opportunity as part of the involvement with the community. It's very interesting that the people are able to say for what they need electromobility. It's a contextualized electromobility. And with this, you can define the technical requirements. Of course, if you want to be very cheap on that, at the end, hopefully you have a basic solution, commercial, very low cost, and you have space to adapt some of the capabilities of this solution to the new context. This is the real one. This is the projected one here in the picture, and here is the final solution of the car with some power electronics and so on. Coming to the end of this part, I want to show you here the remarks about the methodology. The traditional approach in the design is that the design is developed by a technical team, could be a very good technical team. And in the co-construction, we hope to develop that the development will be jointly between the technical team and the community. This is the difference. Operation and maintenance is mostly dependent on external technical support. in the co-construction scheme, installation of technical capacities in the community to allow the inhabitants of the territory to operate and maintain the project, as mentioned before. In the management of the technological application, normally defined under technical criteria, externalized or not considered. And in co-construction is developed jointly with the community based on giving relevance to the local reality or context. And finally, the beneficiary's role is the communities are usually passive receivers of the solution. And what you want to have in this new context is the community plays an active role and participates of the fundamental decisions that define the project. It's not easy to achieve normally. In our experience, it's very hard. We are working now in Arica and Parinacota. It's the first region in the north in a 5 years project. And very common issues like you make a plenary session to explain the things and you receive 20 persons for the decision or 30, and you make the next plenary session and half of the people were not in the first. So because the people need to work in other things, they don't have time. So how you really engage during the process is really challenging for us. Let us move. I talked to you about our experience in the co-construction methodology. Let us move to the planning tools. Normally, the approach is the traditional one, and we follow this type of structure too to make a pre-feasibility. If you apply to the project, the design, basic engineering, implementation, operation, and maintenance. This is the way we need to work for this type of project. What we have is project socialization, basic information, the profile evaluation with technical scenario, community management, and finally the selection of the best solution. This is why we see that. This is not exactly co-construction, but in the way you deal with the real project. And you will face near or similar approaches, one from NREL. In a general manner, I put you here the links to we don't have enough time to discuss in deep all the details, but if you are working, perhaps you work on these topics too, you can download the full explanation. But let us go through more the well-known approaches like the NREL one. Step 1, identify site needs, which can be considered also these community issues. Classify loads, classify distributed resources, evaluate generation load match, like the coherence. You know that Homer was developed by NREL, and it's exactly the way they work. Develop control strategy after that, and finally determine the equipment specifications and go to the project. This are the typical steps for the design of a microgrid. The same NREL, you can again see this type of design analysis, all the data from the same is another point of view of the same picture. Existing generation, if this is not greenfield planning, you have an existing scenario that you will to develop for the future. Design analysis like detailed electrical model, power flow, dynamic stability, short circuit controls, communication, cybersecurity, and go through the final step for verification and validation. This can be a very key issue, not for villages, cybersecurity, but if we go to more cities and bigger solutions for microgrid, this can be a very critical aspect of the design. There are other planning tools that we know. In our opinion, all the tools are good, but there are no tool that really helps to push a button and to receive a result. And I hope with the previous explanation you understand that this is a tool. And for us, the tool is a way to explore solutions that will be used for a discussion in a dialogue with the community. And with this type of tools, you can use RedScreen, Hoga, Lab, DERCAM, and other approaches that can be adapted. Today, if you go in a more wide sense to incorporate also thermal loads and other issues, you can go to Transys. It's a powerful tool in that area. But what we use usually is Homer as a tool to produce solutions for a further discussion with the community. I will show you that a little bit later. This is the EPRI overview. Again, you can find also this on internet. Inputs, electrical, thermal loads, electricity and gas tariff data, distributed energy resource data, site weather data. You have the objectives, minimize cost. Today in microgrids, there are many motivations. And of course, the minimization of emissions can be, and also the objective can be exactly a target of renewal penetration. And your question for the design, what is the optimal mix of this penetration of renewals? Wind, solar, biomass. And this is the tool that you need to explore and not to develop a minimum cost solution at the end. So outage, duration, etc. You have constraints that you can add if there is not in the objective function with some penalties. You can add these requirements in constraints. And finally, you have an optimal output for the mix and capacity, which will be the design. But also, you will have a first impression how need to be the dispatch of the distributed energy resources. Close related with this, in real time, you need to have an energy management system. And in the second part, I want to talk to you about this. Investing and financing and quantitative cost-benefit analysis. So it's a very nice picture to put all together in this modeling area. If you let me go back to the example I show you, we have an experience in Romeral and other topics. Here first, we made a cadastre for Chile to explore all the locations where we can develop microgrids. And we arrived to 84 locations in Chile. It's also published at the end I give you the list of the things that we publish. And this is the priority based on the present value of the cost. If you go and say we need to do first the least cost solution where we will have more impact, and the solution from the technical point of view is much more stronger, what we see is that the most interesting solutions are in the northern part of the country, and this is close related with the latitude, and the priorities like this. But if you incorporate, like the things that we incorporate in the picture, the index of human development, and you put these two objectives together, and you apply this to the previous picture, you see a reordering of the two aspects. When you want to achieve, depending on of the weight you give to the two issues, you can achieve in the south very important solutions in the priority, better to the north, in a combination of the impact like this here. This solution moved to this priority because of the Human Development Index. And what's the idea behind this picture is to show you that with analysis, this is not for one location. For many locations, you can also combine in a multi-objective way the prioritization of microgrid solutions. Now for the specific case of Romeral, which is a small location. This is not Huatacondo, it's a second or another project. We explore different solutions. It was 39 houses, 4 public buildings, and only 3 kilometers far away from the distribution line. And in that case, the strategy was another point that you will face normally in these projects is that the people say, the donor said in this case, the donor was a mining company, no, a generation company. They said, we only have budget for a first step, very limited, but show us a roadmap. We want to make that in 3 steps. And we developed that. First step, to provide energy to school, only to the school, and to some facilities that are compatible with the extension to a local microgrid for the whole village, and later the interconnection with the distribution system. So this was our very smart idea. And we put that in the concept, so you can see that we reuse most of the solutions for the school are reused. We add an inverter, and we develop this microgrid. At the end, the real history was that the stakeholders that were not involved in the whole procedure, especially the distribution company, they arrived to the local authorities that it was a very stupid idea to develop the microgrid, because the distribution company, when they decide to be part of the project for the extension, and they observe that they will have local generation, it means that the net load is lower and they will receive lower income, because this is the way you pay to the distribution company. So the microgrid in the current structure of our regulation is a risk for the business of the distribution company. And today we have a school isolated from the town where the distribution line was extended, but without consideration of microgrid compatibility. Again, how you model that in Homer? Of course, you can do that. It's part of a much more insider design. What was our failure? Not to incorporate all the stakeholders from the beginning, like the distribution company. And we report that in a document that humanitarian activities from the IEEE, they make a yearly report, which is called failure report. And we add our failure, and we discuss this a little bit more in detail. It's a nice experience that we want to share with the rest to avoid the same error for other people in the context. But before that, we made, in our opinion, a nice discussion with the community. Here you can see the solutions, again the same picture, but now I want to explain you these dots with colors. This is the maximum capex. The budget defined by the donor was 100, no more than that. So you explore all the solutions, and you know that solutions that are on the right side of this line are not feasible from the point of view of the donor. Second one is the monthly payment limit. We explore what is the capability of the people in the town to pay monthly. This means 16,000 pesos, like today $30, more or less. This is the limit to pay. So the feasible area for us was in this space. Again, nice, because each point is a result with one of the tools, for example, with Homer. And you can then explore the specific solution. This is the minimum net present value of the and this is the best solution from the engineering point of view. You can say if you include uncertainties, if you really deal with all the risks, etc. But in a deterministic way, you have this as the best solution. Second, the mean OPEX is this. This is the solution with the minimum operational cost, a nice solution, because this is a solution where the people need to pay the minimum tariff every month. So it's attractive, although this is not the best solution. This is when you receive a gift for the CAPEX. Somebody will give you the CAPEX of the capital expenditures, and in that way you will be prone to define this as the best solution. You have a solution that the minimum CAPEX, very attractive for the donor, or for people in the town, if they say, okay, let us do that, we are under the limit of payment, and let us use this for the soccer or a new gym, or because they are bargaining with the donors. So this also can be an attractive solution. And finally, the minimum replacement cost, which is very strategic, as mentioned before, the replacement cost of the storage system. The people need to work, because if you use pump acid, in the case of Guatacondo, we need to replace the Trojan batteries. Really, some of you know the 105. We used that in Guatacondo at that moment. Today we use gel batteries, and you can move to lithium. But at that time was this type of batteries. If you want to maintain the system in operation, you need to replace the batteries, and you need to pay that for. And this is the minimum replacement cost. Could be interesting as solution. It surely is a cost that has less storage and more photovoltaic to move during the day. Going to the end of this first part, let me talk to you a little bit. This was the final comment about Romeral, about our experience in the Eastern Island, where the question for us from the Energy Ministry was to develop the energy plan, not to develop the solution. So it's like stage 1 and 2 from the methodology. So not to cover all the stages of the methodology. And in that case, you can see here during the discussion, this is the airport zone, a constraint, archaeological density. So the people were open to establish that not all the sectors of the island has the same archaeological density. And after many discussions, when you arrive to that, you open the space for a location of some units. Eroded zones, national park zones, shadows at noon, wind resource, solar resource after constraints, wind resource after constraints. So if you put all the filters, you can do this type. So these tools are of prime importance if you go to a territory and you need to deal with the design of a microgrid. But only with this you are able to figure out where is the best location with a tool like Homer, with distance, that you can manage some potential locations with the transmission line cost as an alternative, and the software will select the best one, taking into account the losses and other impacts. What we developed with them was, I want to show you at the end of part 1 a little bit the same files that we use in the Homer study, but if you show to the island people in a workshop with them like this, the Homer outputs, nobody understands, nothing. They are very nice outputs. So the graphics are beautiful, but beautiful for engineers, not for a discussion. We define this very basic interface to discuss the main indicators for the people in the island. And this is the business as usual scenario for 2030 for the island. Of course, I go back to this. We explore 30% of renewable scenario, and we explore many scenarios with them. And we discuss at the end a selection of the scenarios to arrive to the best solution for the people in the island. And the things that were important for the people was, first, to understand in one picture what are the energy mix that you are showing me. And you can see the difference in the case of 30% of penetration and this. And so the picture needs to show the energy mix you are discussing. And second was total cost, co-impacts. These two ones that are strange at the beginning to at the end. Average cost is like the tariff, the land use in hectare to compare with something, the installed capacity from the different technologies, the energy from the different technologies, and the emissions, CO2 emissions, which were very important for the people in the island. And after we define a business as usual case, we compare all the other scenarios with the business as usual case. And that was the way, for example, here with the 30% of renewable penetration, we need to say that we will use instead 5 hectares, 8 hectares. This is not a gift. You want to have renewals, you need to use more space from the island. The composition, you can see diesel generation in this case remains a lot. You can reduce the emissions with these strategies, and you can reduce the cost, because you will see that the average cost, and this was in 2015, so we work with the new numbers of the renewables in this new era. So we achieved some good prices. Let me explain co-impacts and reliability. These are very qualitative. How you say what are the co-impacts. And what we defined with the people was like, again, a traffic lamp, and to have a discussion about advantages and disadvantages from the point of view of labor market, of risk for the recycling, in the island. If you have too much storage with batteries, you have byproducts and you need to manage them. So we discuss all the aspects and compare with the business as usual, which was the previous one. They arrived to a conclusion that from the co-impact point of view, with 30% of renewal, you move a little bit positive in that area. And this number is not developed by us. We were only the facilitators of the discussion about the advantages, disadvantages. In the case of reliability, it was a more technical one, was a combination about adequacy and security of the system. And again, in discussion with the community, we arrived to a number that again moves in the positive way with this 30% of penetration. These are the type of tools that we develop for the design of a microgrid in a co-construction scheme with the community based on that. And we arrive not to one solution. This can be also interesting for you that in this type of studies, excuse me, you need to do something with the minicam? So I can do that? Okay. Okay. At the end, they remain a group to say we need to discuss if to following the current paradigm with basic strategies is valid for some people of the island, like the business as usual. They identified 2 ways to incorporate renewals. They were happy with renewals, but they see a different strategy. One was the centralized renewal in the island, like one big photovoltaic plant in the airport, in the surrounding area from the airport, plus, and mainly photovoltaic. Wind was not very interesting for the people in the island because of the visual impact. It's like a competition with other structures, and they are not too positive for that. So basic photovoltaic. And they developed a new concept called microisland. When we explained microgrids, the understanding was for us, they live in the island, in the middle of the ocean, so they developed microislands of renewals, like distributed renewals inside this microgrid, like subsystems that are able to interconnect, but to be sufficient from itself too. So interconnection of microgrids. That was the experience that I can share with you in this around, 10 years of discussion of these topics. And if you agree, we are at the end of the part 1. We are good with the time? Let me move to show you how we do that in the interface. And then we move to part 2. We'll see if it works. We hope that Murphy let us wait. Was Murphy. One more try, and now it works. Great. A few seconds, but it reacts here. Yes. So, this is the type of tools many of you already know. In this case, auto-adjusting. This is Homer. And what you see on the screen is the interface. And there are different levels of detail. What you need to, let me load some new case here to show the whole. This first one, this is diesel, PV, and some biomass, was like the business as usual one that I showed you previously. You can load it. In Homer, you need to, this is the Eastern Island example. You need to load some basic options in the network to define, again, the same things I discussed with you. You need to develop the resource, how you will have like solar energy, and you can put in different levels of detail, and we adapt local information and also general information about the solar potential from the island for this specific place. If you have data for hour by hour, you can introduce this data in the software. Can I ask you, how many of you already use Homer or something like this? It's only because all the people use that. It's not a good idea to explain things that you already know. No. It's only to show you all the softwares are very similar. This is with a very good interface, but you can also introduce the wind data. For that, we use the data from satellites, but also the data that we have in some measurement points of the island. So we create outside Homer synthetic series, and we introduce that to the system in different ways. So you can make a lot of work outside the software, and you introduce this part, the part of resources, which is the first part. The components is the second part, and you can add different type of solutions. In this case, we have generators. Let me show you here. We introduce 5 type of generators, the G8, the G5 with different sizes. For example, if you put 0 and 1000 here, the software needs to cover, if it is feasible, if you put only 1,000, it will use this as the option. If you put 0 and 1,000, you will try it from 0 to 1,000 in an interval. What is the best solution? It's like a full enumeration strategy that will use by the software. And finally, you have, again, the resource, the components for each one. If you say PV, what type of PV, if it is fixed, the type of technology, efficiency, and so on. What type of storage, if you add some storage. In this case, there is no storage in the system, so there is a library, you can add it. And at the end, you have also the load evolution in the island. For that, we use previous studies. Let me see. You have the electric loads in the island, and you can define for every day, following a profile that we developed with previous studies like this, how during the year, the full year, the load, the electrical load will be. Yeah? These are the type of input data that you use. When you finish with all this input data, you make calculation. Hope it is connected. And Homer will develop not one solution, it will develop the best solution based on net present value. But you can put different objective functions and you will have more than one solution. This is the lowest cost solution, the net present value of 69.9. All the other values are higher. This is why it is selected as the best solution. It's a traditional approach. And if you click on the best solution like this, you will go to a very nice interface where you can see cash flow, compare economics from the different solutions, the electrical summary, how, for example, generation 1 will operate during the year, generation 2. Very nice for us, for engineers. It's a beautiful view of that. Nevertheless, this is a very bad strategy for discussion with stakeholders in the community. And that is why we translate that to different languages or interfaces depending on the type of project that we are developing. And I think there is a huge space to share this type of interfaces among the different groups to improve the impact or at the end to increase the probability of a sustainable solution. Let me load a more ambitious scenario. This is the 80% penetration of PV and wind in the island. So you load that as a case study normally. Again, you can see here that the network changes because you have a lithium battery, a DC AC converter, the load, electricity, and the different technologies for that. I will make it very quick here to calculate. Here is a nice comment. They put take care here. Let me see if they show that. Let me go again. This comment is related with this penetration of renewals. The comment is you need to go to more careful operation studies and stability studies if you want to arrive to the final question. So Homer looks that the penetration is too high, and they are in this very steady state analysis, energy-based analysis. They are not able to figure out if this is really the best solution. Here is the comment. This is an renewable penetration high enough to cause stability problems, so you need to go. So let me show you here the results of this. And you can see here in the case of photovoltaic, how will be the production during the year. This is the other renewable penetration, and so on. And so you can have a seasonal behavior or to be more carefully after an analysis to be more realistic with your input data. So finally, and I will end this first part, I come back to the main presentation. Again, if you use RedScreen or other software, from our point of view, it's more or less the same today with this. It's good to use, and it's good to develop own tools for some specific analysis. Conclusions of this first part. One of the messages that we want to repeat is the need of co-construction scheme combined with adapted tools is the main message to achieve microgrid development framework that all the people are using. This can be companies, can be groups inside universities. In the case of Latin America, we are in a stage where this is more located in universities and groups, because at the moment there are no companies. Companies are selling installations, and I don't know, Sunny Boy from SMA, and then this is not easy. They need to figure all the technical conditions from the country, so it's a quite a challenge topic today for new companies, but they are not working in that area. And this is a space today in Latin America more located in university, and we want to transfer that to new companies to see an evolution in our context. In the Latin American case, funding is mostly from companies that are interested in social responsibility. We never receive money from the companies where they said, mainly mining companies, they say, we want to see from you innovation, or we want to see from you papers in IEEE. They only say we have a conflict or a risk of conflict with the community, and we believe that sustainable development is a trend, and we are able to have some fund to have this work from the university, but it's social responsibility. It's not innovation. And this is the role that we are working on from our group. Microgrid funding is associated with CAPEX mostly. Supported are not interested on assuming OPEX. So this is a very good win-win situation. That normally the government and companies, they say, I am able to pay you one time a lot of money, but please give me this problem out of my future. This specific situation is very positive in the case of renewals, because renewals are mostly CAPEX. And if you see a good solution at the end could be, and with the trend of CAPEX, it can be very sustainable to work on that. Even though energy efficiency can be promoted at community level, significant energy demand rise should be considered in the design. I forgot to mention that, but in our experience, if you arrive from a 7 hours or 10 hours per day energy to 24 hours, all the people want to be like here, to push the button and to have light, and this is very normal. So you cannot work with historical data to forecast the future in load. It's better to use a reference village or reference evolution from another town to see the future forecast. This is the case in our study, at least. Definition with community of local management structure to ensure correct operation. And the space that we see in Chile, we are now looking for a new distribution regulation, a new law for distribution. And we hope that in this new law there will be options for microgrid and innovative associative models without this perverse incentive that we have today in the tariff models of the distribution companies that impacts both the energy efficiency programs that are not attractive and also the microgrid programs, because it is both are a source of risk for the business today. This is the perception normally. The space for new solutions and the participative process Final message is these 3 areas: environmental, social, and technical, and we put different concepts that are more in one area or in a shared area of the 3 aspects. Ending this part 1, we developed in IEEE, we are just starting to create space for sharing knowledge. It's called Comunidad Solar, excuse for the Spanish here. Comunidad is community, it's very near to English. And the idea is a space where, for example, the failure case I mentioned you can download it from this. And we already have people from Costa Rica, from Panama, from Uruguay, and Chile that are interested to have a space to share experience, to put some results, and hopefully to remove the removal of barriers in the development of this type of solutions for the future. So we are very happy if you go in contact with us and we keep in touch. This are the type of journal publications that we see. When we start with Watacondo, the people talk to us to say, you are crazy because this is against your academic life. I am professor at the university and need to publish in easy journals. And I don't know if in this context this is important, but in Latin America there is a huge discussion if you go and involve your time in real things that are not good for the academic career. This is a bad decision. In our opinion, our experience is exactly the opposite. All these projects today with journals that are really interested to show that, and this is also in the case of IEEE, you can see that we were able to publish some interesting things on IEEE, and only because we are involved in this type of projects. So, in my opinion, there is a very nice win-win situation, the involvement in these new topics with new problems, and how you can reflect that in results in publications. So you can follow if you are interested in some of them. We can share the papers. I don't know, Jose Luis, if you want, we can stop here in the first part, and if there are some comments or some questions related, because we will go more on the technical part in the next slides. Please.
A very common example in the students how communities that are not funded by mining companies, they can develop this kind of microgrids by their own.
Very good question. We face 2 challenges with the funding of mining companies. In Chile, you have generation companies, you have the government, and mining companies. This is our experience. For example, today we are financing these 5-year projects in the north by BHP Billiton in Australia, but BHP Billiton Foundation, which is a foundation for the funding of projects related with sustainable development of communities. With an independent organization from the holding, they receive 1% of the utilities, utilidades of the margin of the companies that will use by this foundation to pay this. Yeah? I will come back to you only to comment. The big problem with this when we arrive to the region is the greenwashing. We need to be extremely careful with the communities to be transparent, to show we are funding by this foundation. They make no difference. BHP Billiton means mining company in Chile, means impact on environment, means that they want to use our territory for the future, and this is a very smart way to gain our voluntad, our will in the future. So it's extremely challenged. So you can work. We are open to work in a very transparent way. We are independent as universities, but you have a source of conflict that is an everyday conflict, or not conflict, it's a real challenge that you need to repeat the messages and so on. And this is the cost, if you want to say, if you develop today projects financed by big companies, in the case of Chile, with the perception that there are hidden intentions. Yeah, that. In our case, we are comfortable until today working on that in an independent way. There are partners and so on, but there is a critical issue. Normally, you will not receive money from the government. There is very limited to do these things. And green funds internationally are just starting. There are some projects. So today, what we believe is, with the new cost of the renewal, especially photovoltaics. I am the director of the Solar Energy Center in Chile, which involves 7 universities, and so I am working for the solar energy in Chile 24 hours. That's my job from the university point of view. We believe that if we remove the barriers with this first project, and we can provide public goods where we explain how to develop good technical solutions with all the issues, and this is free available material, not for the community only, but also for new companies that can adapt this and offer new products. Like this will be the seed to solutions that are cost effective and can be financed in a more conventional way by a bank or by the community itself, because we are able to show that the solution is profitable. We are working to apply today in 4 projects, one in the north for the processing of the wool from the camelids in the Altiplano. They process the wood with solar energy, and we need to show that this is profitable, that they will have more income as the current situation. We use that for fishery. With the removal of arsenic from the water, the shrimps that are in the rivers in the north can be a commercial product. Today not, because of the arsenic. With the solar energy, they can move to a commercial product. We use that for tourism, to push the tourists in the Altiplano, to signing and to the points where the rest points of the people that are making tourists in the Altiplano with solar energy. And we apply that to agriculture, to the processing of agricultural products. These are what we call impact investment. And if we are successfully in these 4 projects, which are mostly microgrids, but more than microgrids in the sense that you look for a final business, then we can say that we are able to do that in a conventional funding way, answering your question. But today we are not at the end of this way, in the middle. Please.
Thank you very much for your presentation. It's, I think, very good experience for all of us and the microgrid as well. I wanted to ask, from your experience related with already established microgrids, is there any example which, for example, you could do without an operator, for example, for this microgrid operating by itself, kind of autonomous, or you need always some kind of supervisory control?
Yes, in our experience, you need a local operator, always. Yes. What we try to reduce at the maximum level is the need of external support. And only in critical, like after a storm, we face, for example, after a storm, the problem with one of the photovoltaic panels. They keep, and that was not able to be solved locally. And so the team today, the university is the team, is able to support this. But we need to move, because if you, hopefully, what you say, this like autonomous system, is the ideal situation, because this is the challenge, that you need to be cost effective. And if you put engineers and more people involved in that, specialized people, if you involve the community, it can be a very good situation, because the local people can pay that. It's a local member, so it's, in my opinion, a win-win situation for the cleaning process. It's like an internal arrangement of a thing that is profitable. I don't have many concerns about to develop local labor opportunities. But if you need a super support network from very sophisticated companies that are able to have an helicopter to come to the town, then we are lost in the future of this type of solutions. So, but in our experience, we need always at least a local operator. This is our experience. The local operator has all the maintenance, the basic maintenance. For example, every week the checking of the water level or the level of the batteries. You need to have every 2 weeks an equalize, or every month to equalize the batteries. You need to take care if there is some problem in the synchronization. We experience some problems, some basic problems. It's not high-tech technology, but if you want to integrate heterogeneous technologies and you are not forced to buy the full SMA kit or the full General Electric microgrid solution, and you want to combine the local generator, which is a normal diesel, with a photovoltaic panel, with some good inverter available in the local business. If you want to combine heterogeneous technologies, then you need to adapt for example, the transition. One not easy transition is when you are full. At the end of the day, you are full solar, and you start the diesel generator, and you need to make this synchronization. And what we made was to replace the control of the generator by a Woodward brain. It's only this part. And in the SCADA system, we need to make this sophisticated procedure, because all the noise that you face during the transition, when you have an own developed inverter for the battery energy storage, to transition to the master operation of the generator. And if it fails, from some reason, you need the local operator that is able to restart the system or something like this, and to understand what is the solution. These are, but mostly it's maintenance, and to be careful if there is some issue, some operation issue during the system operation. Yet this is our experience, what the local operator is able to do. We have in Watacondo, we have a lot of data. We can, and we are willing to share that with the colleagues of Canada, with Claudio Cañizares. They also have data that is in some way able to share with Casabonica. I will show you an example in Canada. So there is some data depending on what you need. We can start to sharing that. We have a lot of information, forecasting of loads and so on. Yes, this is the idea to share with other groups. It's okay?
Do you need